Imagine you are an air traffic controller. You click your mouse to route a 747, and your screen freezes for like 3 seconds just because a cable under your desk got bumped.
Yeah, that is not an option.
Right. In high-stakes environments, that kind of failure just isn't an option at all, which is why the actual computer you're using might be hiding, a football field away, connected by a $700 metal box. So, okay, let's unpack this. Today, our deep dive takes us into a highly technical spec sheet from the AV retailer HDTVSupply,
And we are looking at a device called the Smart-AVI SDX-XT-4P-RX-S extender receiver.
which is quite a mouthful. I mean, but the core problem it solves is actually pretty wild. How do you physically separate a computer from its user by a massive distance without ruining the experience?
Well, because normally your monitor, keyboard, and mouse, they are tethered to a loud heat-generating tower right under your desk, or maybe in the same room.
Exactly. But this smart AVI receiver totally changes that geometry. It takes 4 high-resolution DVI-D video feeds, and those are 1920 by 1200 resolution, by the way.
Which are heavy, uncompressed digital video signals. Yeah, very heavy signals, plus your USB 2.0 keyboard and mouse data and stereo audio, and it extends all of that up to 500 feet away.
And what's fascinating here is that it does it all using standard CD5, 5E, or 6 cables.
Wait, those are just the cheap plastic internet cords you probably have stuffed in a junk drawer at home, right?
Basically, yes.
So it's essentially stretching the eyes, ears, and hands of your computer a football field and a half away
Right.
over a cheap internet cable.
Right, and doing it over cheap copper wire is a serious engineering feat. Usually when you push that much high bandwidth data over 500 feet of basic Ethernet cable, you get massive lag or, signal degradation.
Sure, like a choppy Zoom call or something.
Exactly. But this spec sheet notes it transmits uncompressed video with less than 1 millisecond of latency.
Less than a millisecond. Wait, how is it physically pushing 4 heavy video feeds through a basic internet cable that fast? I mean, that seems impossible. Well, it comes down to the specialized processing inside the receiver. Instead of wasting time compressing the video into a smaller file size and then decompressing it on the other end.
Which is what makes consumer gear laggy, right?
Yes, exactly.
Yeah.
This device perfectly synchronizes the raw data streams across the different twisted pairs of copper inside that CT5 cable.
Oh, wow.
So it moves the raw data fast enough that the user experiences zero lag. It literally feels exactly like the server is sitting right next to them.
Even though it's safely locked away in a, climate-controlled server room somewhere else.
You got it.
Okay, so that explains the performance, but let's talk about the price. Regular HDMI cables or simple USB extenders cost, what, maybe $20?
Yeah, around there.
But this device costs over $700. And the spec sheet justifies this by highlighting its uninterrupted emulation. But I'm going to push back here. Wait, isn't it just a really long wire at the end of the day?
Well, no, not quite.
Because if my mouse unplugs at home, I just plug it back in. It takes a second. Why does emulation actually matter for organizations paying this massive premium?
Because of what happens at the operating system level when a piece of hardware disconnects.
Yeah.
At home, if your mouse unplugs, your computer registers a hardware disconnect.
Right.
The OS pauses, it drops the USB drivers, and when you plug it back in, it recalibrates. It takes maybe 3 seconds.
Which is annoying, yeah, but fine if I'm just browsing the web.
Exactly. But if that 3-second system hang happens during a complex medical procedure or a live national broadcast, it is catastrophic.
Oh, man.
That is a mission-critical environment. So what this device does is constantly fake or emulate the keyboard and mouse connection to the main server.
Okay, I like this. How so? How does it fake it?
Think of the extender like a highly trained body double. If the VIP, the physical mouse, gets bumped and accidentally unplugs, the body double immediately steps in front of the cameras.
Oh, I see.
The receiver keeps sending a perfectly healthy "I am a mouse" signal to the main server. The public, or the server in this case, never knows the VIP left the room.
So the operating system never hangs, it never drops the drivers, and the workflow just doesn't miss a beat.
Right, exactly.
But wait, if it's permanently faking the connection to the server, how does it handle a situation where the mouse actually does break? Does the server just blindly keep waiting for data from a dead piece of hardware?
Well, that's the beauty of it. The server thinks the hardware is fine, so it doesn't trigger a system-wide hardware error or freeze up the screens.
It just stops receiving movement coordinates.
Yes. So when you swap out the broken mouse for a new one at the desk, you completely bypass the entire new hardware-detected loading sequence.
The body double steps aside, the new VIP steps in, and you are instantly back in control.
Precisely.
Ah, I see. It isolates the physical hardware failure from the computer's operating system. That fundamentally changes how I look at this. We're talking about the invisible infrastructure that literally keeps the modern world from freezing up.
Absolutely.
Yeah.
It's about guaranteeing stability and isolating users from the messy realities of computer hardware when failure simply isn't an option.
So here's a final thought for you to take away from this deep dive. The next time you find yourself in a massive, quiet space, maybe a security control room or a specialized clinic, and you're staring at a bank of perfectly synced monitors, look around, ask yourself, where is the actual computer and what invisible 500-foot tether is secretly holding the entire operation together?